understand this A star algorithm, let's take this example, 5 by 5 grid, and where this red cross mark cells are the cells in which we are not allowed to enter, and this 1 cell is the source cell, and 5 is the terminal. So we have to find a path from source to terminal cell without getting into the blocked cells, and at the same time make sure that we use the shortest path. So many paths may be available, but we are interested only in the shortest path. Okay. Now what are the things done is from source we can just keep looking at each of the possible ways. So from source we can go to the cell 2 1, so it's 1 step away, 3 1 2 steps away, 4 1 3 steps away, 5 1 4 steps away, 5 2 5 steps away, 5 3 6 steps away. Then we can go upward 7 8 9 10 11 12. From this 9 we can go this 10 11 and this 12. Instead of going this way, if you had come this way, then it is 11 12 13 and 14. So these are the various things we could think of. Okay, then what about heuristically found the h values? So h values we are using the city block distance. So it says from 1 1 1 2 3 4 steps away in the row, 1 2 3 4 steps away column wise. So that makes 4 plus 4 8. Then 1 2 3 4 5 6 7. So that makes 7. 1 2 1 2 3 4 5 6. So that makes 6. 1 2 3 4 5. 1 2 3 4. From here 1 2 3. From here 1 and 2. From here 1 2 3. 1 2 1 2 3 4. From here 1 2 3 4 5. So 5 is written here. From here 1 2 3 4 5 and 6. 6 is written here. 1 2 1 2 3 4 5. So that is 5 4 3 2 1. So from here it is 1 2 3 4. So all h values are also written. Now what next? So let me just get it to this side. The same thing is copy pasted here, so that makes the things. So we start from 1 1. So the g value is 0, h value is found to be 8, so g plus h is 8. Then we go from 1 1. There are two possibilities. I either go to the right or go down. So if you go down, then it is you are going to 2 1, and 2 1 means g value is 1, h value is 7, so that makes 8. And you can go to 1 2. If you go to 1 2, the g value is 1, h value has become infinite, therefore nothing. So there is 8 and infinite, so 8 is selected, that means we go to 2 1. So from 2 1 again we have two options, 2 2 or 2 3. So if you go to 2 1, you go to 3 1, then it is 2 plus 6, which is 8. And from 2 1, if you go to 2 2, then it is infinite, nothing, not possible, this we cannot go. So it says 8 here, 8 here. Then from here you can go this side, so we could go only downwards. So we go to 3 1. So once 3 1 is done, then we can go to 3 2 or 4 1. So 3 2 is not possible, 4 1 takes you with 8. So go to 4 1. From 4 1 you can go to 4 2 or 5 1, and 5 1 says it is 8 4 2, not possible. So from phi 1 it is only phi 2 possible. So which is again 8. From phi 2 you can go up or right. So going up is not possible. Going to the right will make another 8. So you go to phi 3 and then from phi 3 you can go up or right. Right is not possible. Going up will get you 10. So we'll go to 4 3. From 4 3 it is left, up, right. So left, up, left and right have no possibilities. So from 4 3 going to the left or right, but only going to 3 3 is advisable. So from 4 3 go to 3 3, which is 12. So from 3 3 again this side, upside. Therefore only upside, that is making 14, is possible. So once you are here, you can go left, you can go top, you can go right. So going top means it makes 16, going left is infinite, going right is 14, therefore 14 is advisable. So go to 2 4. So from 2 4 you can go top or go right. Going top is 16, going right still 14, therefore go to right, which says 2 5. And once you are in 2 5 you can go up or you can go down. If you go up it makes 16, if you go down it makes 14, so better go down to 3 5. Go down to 3 5, and once you are in 3 5 then you can go left or down. Going left is infinite, going down to 4 1 will make 14, going to 4 5 will make 14. Then once you are in 4 5 then going to 5 5 will make 14. So finally we reached 5 5 with 14. So how did we come? So we came from 1 1, we went to 2 1. From 2 1 we went to 3 1. From 3 1 we went to 4 1. From 4 1 we went to 5 1. So all these tick marked I am using. And from 5 1 we went to 5 2. From 5 2 we went to 5 3. And from 5 3 we went to 4 3. And from 4 3 we went to 3 3. And from 3 3 we went to 2 3. And from 2 3 we went to 2 4. And from 2 4 we went to 3 5. From 2 4 we went to 2 5. From 2 5 we went to 3 5. From 3 5 we went to 4 5. And from 4 5 we went to 5 5. So that's the route we had taken. So that's A star logic, which is talking about this. Yeah, there is still confusion that we have already found this whole path, then why not use directly this? Yes, there is always a problem. Then we can see how this can be solved without actually knowing all these pink values. If pink value was green values, if the green values were already known, there was no need to do anything, because it is telling you are getting a path. But only thing is this you are able to conceive because the whole thing is available parallelly to you, but machine cannot see that way. It has to work in this tabular way and then decide it. So what actually he did is 1 1 2 2 1, then 2 1 2, 3 1, then 3 1 2, 4 1, then 4 1 2, 5 1, 5 1 2, 5 2, 5 2 2, 5 3, 5 3. Sorry. Yeah, 5 3, 5 3 2, 4 3, 4 3 2, 3 3, 3 3 2, 2 3, 2 3 2, 2 4, 2 4 2, 2 5, then 2 5 2, 3 5, then 3 5 2, 4 5, and finally to 5 5. This was the route taken. This is what it will tell, and we just marked it on this grid and realized that this was the path. But in reality, the output what you get is this series of cell numbers. You have to understand that way. Yeah, that's it, how A star algorithm works. So let's see many more such things to come. Thanks. Keep watching.